Okay, so I thought I will be able to finish this in 3 videos, but it seems like I have to make another video. This is the last example. It says define T from M2 by 2 to M2 by 2 means matrices of size 2 by 2 by that the transform X on a matrix A and produces A plus transpose of A, where A is some matrix A with elements A, B, C, D and real numbers. So the first part is that show that T is a linear transformation. So remember, there are two conditions that the transformation has to satisfy to show that it is linear. So we start we need two elements. We can start with A, B, and I chose the elements A, B, C, D here and S, T, U, V in B. Well, you can see how I showed that because the T of A plus B will be A plus B is you add the corresponding element. So A first element will become A plus S. Then second will be B plus T. Then we have C plus U and D plus V. So when I take the transform of that, it will give us the matrix back here and the transformed matrix over here. And then we add these two, we get that. Now I take the right hand side of the condition and I see that I end up getting the same result. So these two are same. So we have this condition is satisfied. In the same way we can show the second condition. Now we have to start by multiplying the matrix by some scalar. So for example, the matrix A, I can multiply it by some scalar K or R. I think I used R. So we have to show that T of RA is equal to R times T of A. So RA will be something like this. So this is RA, and when I take the transpose, it will give me this matrix plus its transpose. And then when we add those, we end up getting a matrix like I have shown here. And then we can go to the right hand side, R times T of A, and we can show that we get the same result. Or I actually went from here, took out the R, what I have inside is T of A. Hence T is linear. Second condition, the second part was said that we have to find a matrix A such that T of A is equal to B. So what is that matrix A? Such that B, the condition on B is that it is same as its transform. So what should be our matrix so that we get B as an answer? So what should be the matrix A such that when we do the transform T of A, we should get only B, not B plus B transpose. So so we say, okay, we know that B transpose is equal to B. So if I say do T of B, then it will give me B plus B transpose. But B transpose is equal to B. So I replace it over here, B plus B, which means 2B. Now, so it means our A should be 1/2 B. So if I do the T of A, 1/2 A, then that should give me the resulting result that we want. Next, we have to check that if B does not is not symmetric, then this will not happen. So what is kernel of T? As kernel of T will be all the matrices in M2 by 2 such that they map onto the 0, 0, 0, 0 matrix, or the 0 matrix having all 4 entries which are all 0. So you will just pick any matrix A, write its image you get after applying the transform, and set it equal to 0, the 0 matrix, which means now each corresponding entry is 0. So 2A is equal to 0, B plus C is equal to 0, and then 2D is equal to 0. Now these two are giving us the same result or same equation, so we can write it only once. So first gives me B, that A is 0, and the third gives me D is 0, so A and D should be 0, but in the B and C place we can have B and negative B, so a number and its opposite in this diagonal. So these type of elements will be mapped onto the 0 matrix, and this will give us the kernel of the transform. So that's all for this section. So we will now look at section 4.3.